We learned the exponential function. Now we're going to learn a new function. I'm so sorry there's so many functions in this pre-calculus class, but I don't know, I guess you like it. So what we're going to learn today is called a logarithmic function, or we just make it shortcut log function. Logarithmic functions. Okay, we're gonna talk about that. Okay, so we learned the exponential function, and the logarithm function is the inverse function of exponential function. What does that mean? That means f of x equals b to the x. That's the exponential function, right? Okay, or you write y equals b to the x. Okay, and do you remember how to find the inverse function? Yeah, we rewrite that as y, and then we switch x and y so that x becomes b to the y. And then I need to solve for y. How do you solve for y? We need to do something. Okay, we need to take log on both sides. Therefore, I get y equals log b x after I switch it. Okay, so this one is the log function, and this one is the exponential function, and they are inverse function of each other. And if you compare these two, did you notice that a b and a b here? B is the base of the log and also the base of the exponential. So I ask you to remember this. Remember, okay, base is always the base. When you deal with exponential and the log, remember, base is always the base. That will help you. And then you're going to switch the exponent here to be here. And then this y, the exponential value, becomes this. What does that mean? Okay, I'm going to give you more detail here. One thing, 2 to the third power, you know this, 2 to the third power, which is 2 times 2 times 2, which is 8. If this is exponential form, if I rewrite that into the log form, then that becomes 3. This exponent is log base 2 of 8. Okay, see, from this exponential form to the log form, base is always the base, but you switch the other two numbers. So we do this a little bit more so you get familiar with this. So what about a 3 to the 4th, which is a 3 by 3 by 3 by 3. So that's 81. If I ask you to write that in the log form, then that will be 4, the exponent, 4 will be log base 3 of 81. Okay, so try more. 10 square, which is 100, right? And then 2 equals, I write in the log form, log base 10 of 100. Okay, and 10 to the third, of course, that's 1,000. So 3 is log base 10 of 1,000. All right. Okay. So there are two things I want you to know. One is log 5. Log 5. If you don't see the base, which is the same as log base 10 of 5. If you don't see the base, which means the base is 10. If the base is E, do you remember E 2.7 something? And then there's a way to write it. We just write ln. So if you see ln, which means log base E. So this is just a special notation for that. So if you see just a pure log, no base, which means base is 10. If you see ln instead of log something, that means a log based E. Okay, so next thing I'm going to ask you to write from this form to this, or from this form to this. Okay, let's do that. Little exercise will help you to understand. Okay, so if I give you 2 equals log 5x, this is the log form. Can you write that into the exponential form? Base is always the base. And then after 5, I need to write 2 instead of x. And that equals x. Actually, we know that x is 25. But okay, I just ask you to write it in another form. So one more. So 3 equals log b 64. Rewrite. Base is always the base. Here's a b to the 3rd power, which is 64. And we know this. We know b is 4. But no, I'm not asking you for that. So the next one, I give you this. Log 3, 7 equals y. Write that. This is the log form. So that means I ask you to write in the exponential form. Base is always the base. And then I'm going to put a y, 3 to the yth power equals 7. It's good? Okay, next one. 12 squared equals x. This is the exponential form, so it's going to be log, base is always the base, and then of x equals 2. Okay, so what about this one? B to the 3rd power is 8. This is the exponential form, so I'm going to write in the log form. Base is always the base, b here, and of 8 equals 3. All right, last one. E to the yth power is 9. Okay, let's rewrite that. Base is the base, log base, that will be the ln, right? Yeah, and then ln 9 equals y. Okay, so we do like a backwards and a forward. I write from the log form to the exponential form, or from the exponential form to the log form. So I just want you to be familiar with this, okay? So once you're familiar with this, then we can calculate some number, or we can evaluate. Evaluate the following. Log 216. I don't know. So, but if just assume that this is x, the answer if it's x, then we rewrite that into the exponential form, which means 2 to the x's power is 16. And we know 2 to the 1st is 2, 2 to the 2nd is 4, 2 to the 3rd is 8, 2 to the 4th is 16. Get it? That's a 4. So when you take a log function, actually you're looking for that power, right? Sounds good? Next one. Log 7, 1 over 49. Again, 7 to what power? I'm asking for 7 to what power is 1 over 49. Can you write a 49 as 7 squared? And because it's in the denominator, so the power, if I bring that up, it's going to be -2. Did you get the number you're looking for? See? -2. Okay. Next one, log base 25 of 5. We're looking for 25 to what power equals 5. And we know the square root of 25 is 5. And the square root means the power of 1/2. So that's 25 to the 1/2 power is 5. Okay, so the answer in this case is 1/2. So you're doing log, which means you're looking for the power. Okay, so the next one, log 2 5th root of 2. 2 to what power equals 5th root of 2? If you rewrite this from this root form to the exponential form, it's going to be 2 to 1/5 power. So whatever you're looking for, the power is 1/5. So that is 1/5. It's not bad, huh? Okay, a couple of more. Log 7, 7. So we're looking for a power, 7 to some power Base is the base. 7 to what power is 7? We know it's 1. 7 to the first power is 1. Okay, last one. Log 5, 1 equals. So we're looking for 5 to what power equals 1? 5 is not a 0, so any non-zero number to the 0th power is 1, so that answer is 0. Okay, so this is how you evaluate those logs, and based on the definition of it, if you write that into this exponential form, that will help you a lot. But eventually you're going to be very good at this because you can do this very fast instead of writing things in this exponential form. All right, now what we can tell from there is log, if we have a b of 1, that's always 0 because b to the 0th power is 1, isn't it? And log b to the b, log bb, which is 1, because b to the first power is b. You see this? Okay. Okay. Then we're going to go log b to the x equals, guess what, is x, because base to the power equals b to the x. Okay? Good. And what about this one? What about a b to log b x is also x. Okay, so the power is log b of x. So log b of x equals log b of x. Okay, so this is a property I want you to know. You have to be very good at that. You have to remember this, okay? Or you have to know this by heart. Once we know the property, I ask you one. I give you a quick test. What is ln 1? Log 1 of any base is 0. And what about ln e? If the base here is e, here is e, so that is 1. Okay, so what about ln e to the x? And that would be just x. And what about e to the power of ln x? And that is also x. So this is just a special case of the property we did a little earlier. Okay. All right, now we know something about this logarithmic function. And then next thing, for any function, the next thing will be graph. And after graph, we need to know domain, we need to know range, and we need to do transformation. That's what we're going to do. Okay, that's the rest of this class. So f of x equals 2 to the x. We know how to do that. We already did it. So it's 1, and here's 2. Remember that? This is f of x equals 2 to the x. Okay. Can you graph the opposite log base 2? X, not the opposite, the inverse function. Okay, I want to tell you that the relationship between two inverse functions. The two inverse functions graph is going to be symmetric along this 45-degree line. Therefore, if you have your f function, the exponential function is here, and then you just flip along the y equals x, this 45-degree line, and then that would be your log function. So it's going to look like this. And this is g of x equals log 2x. All right? If you want, of course, you can choose the x value and then choose the y value, and then you can do it. But anyway, I just tell you that it's a symmetric. For the inverse function, their relationship between the graphs, they are symmetric along this y equals x, which is the 45-degree line. Okay, after we know this, domain. For the log function, what x value can be? You see? It has to be from 0 to past infinity, isn't it? Yeah. And what about range? Range is what a y value can be. It can be anything. So that's from negative infinity to positive infinity. You agree? So that is the domain and range. This is the case when this base is greater than 1. And there's another case, I don't know if you remember that. It was this. And this is y equals 1/2 to the power of x. This is when the base, the b, is between 0 and 1. It's greater than 0, it's less than 1. So how do you draw the inverse function graph? Because it's going to symmetric along that. It's going to be, looks like this. So this one is going to be log. Base is going to be 1/2 x. So this is, so here is the inverse function. So you can see that the domain of this one is also from 0 to past infinity, and also the range is from, can be anything, all real numbers. So no matter what the base value is greater than 1 or less than 1, still positive, then the domain and the range should be the same. Okay, the domain is always from 0 to past infinity, which means you're not going to take the log for a negative number. And then the range, which means it can be anything. Okay, so next one, domain, range, transformation. Okay, so let's do that. Okay, I give you the graph. F of x equals log b to the x. Okay, I ask you how to get the graph of the new function log, okay, y equals, or f of x, g of x, whatever you write it. Okay, that's log b x plus 5. So if you have the graph of this parent function, in order to do that is you do the parent function and you shift up by 5. Okay, let me just put a g of x. Okay, and then one more, g of x equals, let me change it. Let me change into log b of x minus 5. So that's just shifted down by 5. Okay, next one. What about g of x equals log b x plus 5, which means you shift it to the left by 5. Okay, and the g of x equals log b x minus 5. So from the graph of the parent function, you're going to shift it to the right by 5. Is that good? All right. Two more. If I ask you to give me the graph g of x equals 3 log b x. Here is the parent function. Now you stretch by 3. Okay, stretch vertically by 3. And if I do g of x equals negative 2 log b x. From the parent function, you're going to stretch by a factor 2, and then you're going to flip along the x-axis. Okay, this flip comes from this negative. Okay, two more. G of x equals log b negative x. See, here is the negative x, so we're going to flip along the y-axis. From the parent function, we're going to flip it. And the last one, g of x equals log b 5x. Because this 5 is the coefficient of this x, so we're going to compress, means we're going to squeeze this to the original 1/5. We're going to squeeze that to the 1/5 of from the parent function. Okay, So this is the logarithmic functions, and then later we're going to do something more, but so far this is all you need to know. You need to know what is the log function and how do you rewrite between the log and the exponential. And since you know how to rewrite, then you can go back to the form that you're familiar with and evaluate some log value, log expression. And there are some important properties of the log. We're going to do more properties. And then to graph it, domain, range, and transformation. Okay, so that is all for this section.